All right, folks. I want to start with Descartes. Descartes in 1641 wrote his book Meditations on First Philosophy, in which he, in many ways, sets both the problem and defines the problem space for much of what's going to happen in early modern philosophy. And it's important for Kant because Kant, in a way, responds to several attempts to solve Descartes' problem. And the way Kant responds to it is by trying to change the definition of that problem space. We'll get to that. Let's briefly just see what Descartes was about. So Descartes, at bottom, tried to justify the epistemic authority of modern experimental science, modern physics, early modern physics. That authority was in question because fundamentally it was in competition with with church teaching. So on the one hand side you have and both church and science were trying to tell a story about the world. All right, now the story the church was telling was about a created world. So nature, let's for all intents and purposes call this world the natural world. Nature was created by God. Nature was, for all intents and purposes, ahistorical, meaning, yes, there was an event at the beginning at which nature was made, but then after that, it basically didn't change. The natural world didn't change. Ahistorical. There was a certain cosmology that went with that, and the cosmology was Ptolemaic, which meant geocentric. And that's to say, according to church teaching, the earth was the center of the universe. Human beings were created as the center of, or on earth, as the center really and the point of God's creation. And then finally, there was a certain perspective on physics. And that perspective on physics is essentially Aristotelian. And what that meant, it's basically teleological. The idea here is that, Aristotle had this notion of the four elements plus the fifth element, and the four elements, earth, water, fire, air, they organize the physical world, and they do so in terms of intentional notions. So earth is at the bottom because earth wants to be at the bottom. Water sits on top of earth because that's where it wants to be, and so on. The idea there is that motion, terrestrial motion, is understood in terms of intentional motion. Things move because they want to move. Now, on the other side of this, science's picture was not necessarily in conflict with the creationist part. So you might say possibly created. Science was, at least not in Descartes' time, as yet in conflict with the ahistorical part. That came later. That came in the 19th century, specifically with the discoveries in geology, and then later Darwin's theory of evolution. So basically, you could be agnostic about the historicity of the universe. The rub was the cosmology and the physics. The cosmology of the early modern scientific picture was not Ptolemaic, it was Copernican. And that, of course, means it was heliocentric. That becomes important pretty quickly for Kant, because Kant defines his own philosophical project as a kind of Copernican revolution. We'll talk about this. There's going to be a separate lecture on that. And then the physics of it was, for lack of a better word, slightly anachronistic, but for lack of a better word, it was Newtonian. I say it's anachronistic because Newton wasn't around at the time of Descartes quite yet, but the idea here is that it was not teleological. Things move not because they want to move, but they move in a mathematically describable way, and there's no point in trying to figure out what the intentions or the aims or the purposes behind that movement may be. All right, so those are the competing stories. Now the question is, for modern science, and the PR problem I mentioned is that, look, what the church was saying was in so many ways extremely intuitive. So specifically, if we look at, let's say, celestial motion, in the celestial case, the church says, well, look, the Earth is in the center, the heavenly bodies revolve around it. So, and that's, of course, exactly what you see when you're a medieval farmer somewhere standing here tilling a field, and here's your horse. What you see is, in the morning, the sun rises in the east. It travels across the sky. At noon, it's in the top, and then at the end of the day, it sets in the west. Who moves? The sun moves. Compare this to the scientific case, the scientific explanation, which is basically to say, well, actually, you got that all wrong. It's not the sun that's moving, you're moving. So intuitively, it looks like the church got this right, because that's, it basically says the way things look is the way things are. Let's go to terrestrial motion. Same thing here. The church story is, or that kind of Aristotelian teleological physics is that things move because they want to move. And that's somewhat intuitive, because you might say, how do things, how does the cart get up the hill? Well, a cart by itself doesn't get up the hill at all. Here's your hill. If you want to get the cart up the hill, you have to put a horse in front of it. That's how things move. Things move because they want to move. Compare this to Newton's first law of motion. The first law of motion, the law of inertia, is that things moving in a straight line will keep on moving unless stopped by something that's in its way. Nobody in Descartes' time had ever seen anything keep on moving and not stop. Again, this picture, the church picture, was entirely intuitive. The scientific picture was rather unintuitive. In addition to this problem with the intuitiveness of the scientific truths, was the fact that science itself was not the kind of enterprise it is today. So you'll think of it, science today is what? It's double-blind, peer-reviewed, it's funded by multi-million dollars, it's housed in research universities and institutes. It's got really snazzy instruments, finely tuned and calibrated to record, uh, what the data are, and of course, it's entirely data-driven and mathematizable. So science in those days pretty much wasn't any of that. It was a bunch of hobbyists looking they're working on their niche interests, and it wasn't clear how what one person was doing spoke necessarily to what somebody else was doing. Discoveries in optics were, in many ways just unrelated to discoveries in gravity and so on and so forth. So basically, there didn't seem to be much rhyme and reason to it. And of course, the instruments, the telescopes that they were using looked to many people more like dark magic than actual and kind of an avenue toward truth. So as a result, the science needed to say, how is it, despite my counterintuitiveness, how is it that how do we know? Now, if you want to explain why science gets it right, immediately, you might say, well, it's just going to kind of sort itself out. You keep doing more and more science, and in the long run, it'll just be crystal clear that the scientific picture of the world is the true one, and the church picture of the world might be something more, mythological, perhaps. But of course, at those time or in that time, it wasn't that obvious. And in a way, science needed an answer today and couldn't wait for several centuries to sort itself out. So, what's a scientist to do? Well, it turns out most scientists really weren't interested in that question, but Descartes was interested in this question. And Descartes basically said, look, in order to convince the church authorities that science is not the devil's work, we're going to have to do something other than simply doing more science, because that's just foot stomping. You're basically, insisting that you're right without showing that you're right. So Descartes thought there's a third way, and that third way is effectively using not empirical methods that science uses, or kind of, either dogmatic or religiously inspired methods that the church might be using, but we can use reason. And reason, Descartes thought, had really kind of a privileged access. Reason would tell us, independently of either church teaching or science, independently of all that, in a direct avenue to explain what sort of the nature of absolute reality was like. So that was Descartes' project. In the next video, we'll talk about the problem that this created for Descartes, and then the problem that he tried to solve.